Hello everyone, welcome to this session on synthesis and Verilog coding. In this session we are going to see how to invoke GLS and run some basic experiments with GLS. Okay, so quickly if we recap, in the last session we saw to run GLS we need the netlist, the Verilog models of the standard cell libraries, and then we need the test bench. We submit all these three to iVerilog, and iVerilog dumps out the VCD file, and VCD file contains the waveform which will be viewed using the GTK wave tool. Clear? So we have some files here. We will quickly have a look at it. These are the files we are going to use for this lab. So first thing we are going to see is let's start with a very basic mux. So this is a called as a ternary operator. This question mark is called as a ternary operator. In Verilog, it's called as a ternary operator. Call this as ternary operator. Okay, it takes three operands. So it comes with the colon also. So here we write the condition. This is the true and this is false. If this condition is true, this will get executed. If this condition is false, this portion will get executed. So a simple way of writing the mux is assign y equal to select colon. If select is true, we will send I1. If select is false, we send I0, correct? So that's precisely what we are writing here. So this is a mux. So let us quickly simulate this and also simulate the GLS for this and check what is happening. Okay, so let's start, and we will also look at interesting synthesis simulation mismatch scenarios in this. Okay, so first let us do the basic RTL simulation. So first iVerilog ternary operator, and as usual our TB will be TB underscore that same thing, ternary operator mux dot slash a dot out. We have the VCD file generator, GTK wave. We'll start with basics and okay, sorry, GTK wave. So clearly it is RTL simulation because if I open, I see UUT alone. I don't see any underscore 1, underscore 2 or any standard cells I'm not seeing. So these are my signals, I0, I1, select and Y. I'm going to make it for full screen. So if you see clearly when select is low, the input is clearly following I0. When select is high, the input is clearly following I1. This is clearly the behavior of the 2x1 mux. Correct? So let me keep this here. Okay. Now we are going to synthesize this. So I will invoke uses read liberty -lib dot slash mylib lib sky. Then read Verilog ternary operator mux. Okay, so we are going to do synth -top ternary operator mux. So it has inferred a mux. Clearly it has inferred a mux here. Let's see what is happening here. ABC-liberty dot slash mylib lib Okay, and then I'm going to write the Verilog, write Verilog hyphen no attr ternary operator mux underscore net dot v. This is the netlist. Show. Let's see what it has done. So this is clearly the mux, correct? This we have seen earlier also. It has, if you look at the Boolean equation, what it has formed here, it has formed a NAND gate using I1 and select. Let's try to trace this. It's a NAND gate with I1 and select, and then I0 is inverted. Then it's a OR2 and invert gate, OR2 and invert. Okay, that means it's OR2 and invert gate, to which the OR gate inputs are A1 and A2. What are the inputs? The inverter output and the select. So this is select, this is the inverter, and this is connected here. Correct? So what we are getting here? Select plus I0 bar, and it is I1 dot cell the whole bar, and this is cell plus I0 bar dot I1 dot cell bar the whole bar. So if I apply De Morgan's theorem, break the bar and change the sign, so I will get cell plus I0 bar dot I1 dot cell bar bar, which is plus I1 dot cell, and if I simplify this, there's I0 bar here already. So if I simplify this, I will get cell bar dot I0 plus I1 dot cell. This is exactly the equation of 2 cross 1 mux, and this is what we got. There is no doubt about what we got. So this is clearly the equation of 2 cross 1 mux, and the same thing we are getting. So let me close this. So we have written the netlist. So let us do the GLS here. So to do the GLS, we need to invoke iVerilog with the Verilog file model. So that will be in mylib. In the mylib area, if you see, there will be a lib folder and there is a Verilog file folder, Verilog model folder. So there you will find the Verilog models of the standard cells. Mylib Verilog models. These are the two files which we need to read for the standard cell models, and then we need to read our netlist, which is ternary operator mux underscore net dot v, and our test bench, which is tb underscore ternary operator mux dot v. So we have all the information here. Slash a dot out. So the VCD file is open, GTK wave. So now I'm going to show you this. How do you know this is GLS? We will see. Now if I open this, we have seen underscore 6 underscore 7 underscore 8. These, there were no underscore 6 underscore 7 underscore 8 in our RTL, correct? So this clearly the, and so I0, I1, select, and Y, and I make it full screen. Yeah, clearly it is following the mux behavior, correct? When I0 is, when select is low, it's following I0. When select is high, it is following I1. So this is how, this is the GLS output. Clear? Fine. Let's go further here.